Okay, hello everyone. I'm going to do a little recap of day 4 because I did not have a video for it. I'm going to start with the parent functions. These are functions that we should know. This is before any transformation has happened, and I'm going to go through these pretty quick. I'm on my phone, so I'm making quick little sketches. If they don't look so great, it's because I'm on a tiny little phone. Okay, so y equals x squared, definitely something you already know what it looks like. Its vertex is at the origin. Y equals square root of x, something I think you probably already know what it looks like. Again, vertex at the origin, that's going to be that B shape. Y equals square root of x. So now if I take the parabola that we had in the first one and I put it on its side and only draw the top half, that is the graph of y equals square root of x. Y equals 1 over x. We've seen this a couple times when we were doing domain and range. This is that hyperbola that I've been talking about. It is in quadrants 1 and 3. And last we have y equals x cubed. Okay. That's not a great picture, but you get the idea that it has a point of inflection. We'll talk more about that later on, but that's not a vertex or an end point, okay? This guy's got asymptotes. This guy has a point of inflection. So these are our parent functions. Half the battle is picking out the correct parent function, okay? I'm going to skip over the next, like the bottom of this page, and go to page, let me see what page I'm going to be on, 11. Okay, we're skipping to page 11 right now. Okay, I'm on page 11. I'm going to do some of the problems that I did not get to in class. This will be good for anybody that wasn't there today. Also good for people who were that just need to see it again. I'm going to start with D. Okay, so this one's a bit of a tricky one. First thing is identifying the parent function. When I look at that and I see the square root, I'm not drawing a parabola, I'm not drawing a V, I'm not drawing a hyperbola, I'm drawing the square root graph. So being able to pick out the correct parent function is really important. Okay, next, I'm looking to see what's happening to it. Any number on the inside that's added or subtracted to x is going to be a horizontal movement. In this case, this guy is moving right 4. How do I know that's on the inside? Well, it's under the square root with the x, okay? Next, I see a negative in front, so that means we have a reflection. Now, there's 2 types of reflection over x and a reflection over y. This is a reflection over y because that negative is on the inside. Okay, so let me erase my little arrow here. Okay, first step, I'm going to move it right 4. Here we go. Okay, from my original to the one I just drew, I moved it right 4. Now I need to reflect this thing over the y-axis. That means it's actually going to jump to the other side and face the other way. Okay, so again, the picture is not great, but hopefully you get the gist of what happened there. Okay, moving down, I'm going to do F. First things first, what's the parent function? The parent function this time is that V. As soon as I see those absolute value marks, I know that's the guy I'm working with. Okay, what has to go first? Horizontal movement has to go first. This guy is moving left 7. Again, we have a reflection. And again, the reflection is over y because that negative is on the inside. it is also moving down 3. That -3 is on the outside, so that's what tells me it's a vertical movement. We should always be doing the vertical movement last. Okay, one thing I kind of skipped over by skipping the middle page was talking about the order of these things. So horizontal movement is always done first. Trying to get my highlighter out. Horizontal movement is always done first, vertical movement always done last. If you can remember that, you'll be all set. Horizontal movement first, vertical movement last. Okay, so let's do this one in steps. I'm kind of running out of room. Let me make it a little bit bigger. There we go. Okay. So, I'm starting with that V. I'm moving left 7. That's going to put it over here. When I reflect it over the y-axis, I'm glad we're doing this again so we can see, it's going to jump over the y-axis to +7. And my final answer is going to be that moved down 3. Now, somebody might be saying, why is it not upside down if we reflected it? Well, it's going to be upside down if we reflect it over the x-axis. Because this negative was on the inside, we reflected it over the y-axis. Okay, one more. I'm going to jump down and do this x cubed one because we didn't get a chance to see one of those in class. So this will be the last example I do. I'm recognizing that this is a y equals x cubed for the parent function. That can be tricky. Sometimes people jump to a parabola. They're not really paying attention to the fact that it's a 3 and not a 2. So we've got a y equals x cubed. And again, as we go through this, let's talk again about the order. First thing that has to happen is the horizontal movement. This is moving left 1. Next thing, reflection. This is a reflection over the x-axis. So the previous 2 examples, you saw reflection over y. This negative is on the outside, so it's a reflection over x. The last thing to happen is the vertical movement. This is going to move down 2. Here we go. Left 1. Okay, so now that point of inflection I was talking about moves over to -1. This one's kind of a weird one to reflect. It does change. Instead of, I'll use my highlighter to kind of show you. You know, if I think about this reflecting to over the x-axis, it's going to end up being like that. Hang on. Like that. Okay, let me go. Okay, I talked in class a little bit about like this is concave down and then we go to concave up. When it's reflected, it's like I'm drawing concave up and then it goes to concave down. So that's what happens after a reflection over the x-axis for that picture. Then I have to move it down 2. So the final result, it's like, let me find a little space here. I'm going to make this bigger. Okay, so I'm going over to -1. I'm going down 2. So that's where my point of inflection is going to happen. I'm just going to mark a point so I know, like, hey, go through that point. And it's going to start going down. There's that little sort of kink in the graph. That's my final answer. Okay. My goal was to make a 5-minute video. We're at 7 minutes, so not too bad. All right, hopefully that's a good recap, and I will see you tomorrow.